Hello, welcome to this particular module. This module is really interesting because if you recall the last lab component, we were discussing each and every or most of the parts within a PVD system, and when we talk about PVD, we were talking about thermal and E-beam evaporation, right. So, in that last module what we were discussing how the penning gauges are there, how the Pirani gauge are there, right, how the E-beam control circuit is there, where is the transformer to apply the power for the boat that we use in the thermal evaporator, right, how the chamber looks like, where are the displays, everything like in a fragmented manner. And the role of this PVD, or you can say thermal evaporator slash E-beam evaporator, is to deposit metals, semiconductors and certain insulators, right. Please focus on this module. This is one of my favorite modules, because actually you will be able to see how the system is in a operating mode, and you will see how the substrate is loaded, where is the E-beam, and you cannot see E-beam actually, but where is a crucible, right, and there are 4 crucibles, and then where is a boat, right. So, how the chamber looks like. So, whatever we learn in theory is one thing, when we look something in the lab or we experience that in the lab is very different thing. So, I hope that you like this particular module, and any questions again you are free to ask me in a forum. So, I will request a few of my students to show it to you, along with we have called the engineer from Hyundai VEC, Mr. Rajanna, and he will show us how the system operates, but we can also operate independently. It is a very simple and easy system, provided you understand the concept. Alright. So, I will see you in some other class. Till then, you take care. Bye.
Welcome to this module. As you know, we use lot of instruments to make our sensors as part of the sensors and fabrications course. You have been introduced to lot of unit processes that are used to make the sensors. So, one of the basic processes is deposition, where you deposit lots of different types of materials on your substrate. Your substrate may be glass, silicon, different types of wafers. So, today we are running you through a system installation in the lab, so that you understand how these things are working and how they are assembled. Okay. So, we are in the process of assembling this system, which is an E-beam and thermal evaporator combined into a system. So, we have people from the company who are installing the system. He will quickly talk to you about the basics of the system, and then we will go into the installation.
I am Rajanna from Hyundai Vacuum Company Private Limited. We supplied vacuum thermal evaporation and E-beam evaporation system. Today we will be starting the mechanical dismantling the packing and start mechanical work. Tomorrow we will be going for start running the system like that.
So, he will talk about different gauges inside, and what are the wafer holders, chuck, everything. We will see each part. To start off, they will install the power supply unit for the machine, and we will see it as it progresses. Thank you. Now, as you can see, we are pushing the power supply unit for the electron beam power supply into the system, into the housing of the system, into the control panel, below the control panel. What you see above the power supply unit is the control panel. So, which is very heavy, that is why we are using a trolley to align with the height of the housing and then push it in. So, above the power supply unit is the control panel.
Okay. Okay.
Now, we have finally pushed the power supply into the control panel housing. Now, we will make the connections from behind. We have made 3-phase connections with a good ampere rating for this power supply unit. And this power supply unit will power the control panel. Separately on the left side, you can see the chamber. The chamber will have its own separate power supply that will be supplied through a dedicated connection. So now we have pushed the power supply unit inside and attached few panels onto it, so that only the knobs that are required to control it are visible outside. So that's how they have assembled it. Now they are giving the connections from backside. We have a very high power socket behind that we have made for installing this equipment. So that is there behind, and we will connect it. So for the system, we need two main additional things, which is a chiller unit and a compressor unit. So chiller unit, actually what it will be filled with DI water, deionized water. So that will basically used for the cooling purposes inside the chamber. I mean not inside the chamber, around the chamber, so that temperature control can be done. And the compressor unit, as you know, would be used for flushing in air, taking out air, creating vacuum and all those purposes. So now they are unpacking the compressor unit which will be installed. With regard to safety purposes, chiller, compressor, gas cylinders, everything should not be kept inside the lab. So what we will do is, we will take these units, and we have a utility room that is made outside the lab with connections coming into the lab. So this system, after it is unpacked, the equipment will be taken out into the utility room, and connections will be taken from there into the system. We have now unpacked the chiller unit. Now Mr. Rajanaji here will explain us the different knobs that are there, because we will be taking it back to the utility room. After that you will not be able to see it. So it's better that you understand what is there, basically how a chiller unit works before we take it. Sir?
This is supply, this is Varnas Inlay make chiller unit. This is the main power supply, main circuit breaker, and fill the DM water. And this is the water level. This should be maximum level.
Okay.
Okay. This is power main. Switch on main. This is a temperature indication. You can able to vary whatever the required temperature.
So what is required for our system usually?
20, 25, 18 to 20 degree.
Okay.
This will be once temperature is going up, automatically compressor is on, vacuum is cooling down. Once it is 18 degree, compressor will automatically cut off. Like that. This is with circulation motor also will be there. For our unit, need 2 bar pressure water chiller, water circulation. It is required 2 bar pressure. This will be able to reach up to 3 to 4 bar water circulation pressure. Okay. Like that.
And other knobs are for LP drip, HP drip, and
if you this is the LP HP drip, means this is compressor on.
Okay.
Pump on. Circulation pump on, this is compressor on. This water level is going down, automatically motor strip. This should be maintained maximum level. If the water level, sometime during maintenance time, what is wastage? Okay. But then slowly water level is coming down. This should be automatically fixed. Okay. Again you have to re-tap the water. Okay.
Refill the water.
Refill the water.
Okay. Okay. Good.
And you have to maintain 2 bar pressure.
So that is a pressure gauge.
Yeah, pressure gauge.
Yeah, this is a throttle wall inside. You have to maintain you can set the pressure.
So how do you set the pressure?
Yeah, inside.
Oh, it's set.
Already set it.
Set it. Okay, fine. Good. Thank you.
This is pressure dial gauge.
You have to maintain 2 bar.
Here. This is
From first. Sir, can you tell from first? This one, yeah.
This is a fan for water cooling purpose. This is water outlet from the chiller unit and water inlet from the chiller unit to the chiller unit. If actually whatever once you fill the water, you can able to run same water minimum 3 to 4 months. After water contamination, you can drain the water from through this wall, drain wall. Clean tank and refill fresh water.
Okay.
So without chiller unit, you can continuous waste, water will be waste.
Yeah, correct.
You can save water and temperature also should be maintained here.
Yeah, so this tube will go around the system.
Yeah.
To cool it.
This tube.
Yeah.
Holding water
extra
line.
tube. Okay.
See, water inlet.
From process. Okay. And that media top up overflow is?
This is overflow. Suppose water is going fill over. This should be
Coming up.
overflow.
Okay, okay.
In the even warm also.
Okay, okay.
In second
that
time overflow will be there.
Yeah.
Like that.
Okay.
Similar.
Okay.
With this unit we can do LT process and HT process come EB1. This major three process is there. You can see this is LT transformer and that is a HT transformer.
Loudly.
With that LT transformer you can move up to 200 amps. By that HT transformer, before initial process you can go with that HT transformer for ion bombardment to cleaning the chamber gazetteries. This is a rotor pump to achieve the initial roughing vacuum. After that, achieving the initial roughing vacuum, we will move to turbo pump. To switch on the turbo pump, it is required some initial roughing vacuum. Without roughing vacuum, we will not move for to switch on the turbo pump. So it requires certain backing vacuum that will provide from rotor pump. So after achieving fine-tune minus 2, we will move to turbo pump to switch on the turbo pump. After getting some backing vacuum, we will switch on the turbo pump. From
Turbo pump is also back side.
yeah, turbo
Have
pump
inside.
this is fitted here.
Okay, okay. Inside the chamber, yeah, above.
Yeah,
You can just point it once.
Yeah.
yeah.
So
This is the turbo molecular pumps.
This is the turbo pump. After reaching roughing vacuum, we have to switch on the turbo pump. Then by using the turbo pump, we can move it up to -6 vacuum and -7 levels.
But so the size wise roughing pump is bigger than the turbo pump.
Yeah, size
Yeah.
roughing pump is bigger. Turbo fitted here.
It's turbo molecular pump, TMP.
In between
This is
chamber
a make Edwards make imported.
in between from chamber to turbo pump, one vacuum, one valve is there. That is called a high vacuum valve. That after achieving the certain vacuum level, we will go for that high vacuum valve.
So manually we have to also open the valve or
Yeah,
close.
manually we have to open. After achieving certain
Actually,
vacuum.
all are electro-pneumatic valve.
Electro-pneumatic.
Electro-pneumatic valve, not butterfly valve. For switching on any valve, need compressed air. Okay, when you have control panel, individual switches, backing, roughing, high vacuum, and vent. This can this toggle switch. When switch on the tire switch on, automatically valve is will be open.
See, initially,
First switch on the rotary pumps. Wait until reach 5 to -2 in the backing line. Switch on turbo. For switching on turbo, you need water also. Without water, it is not getting on.
that is
Turbo will not-
Turbo is not switched on.
Water for the cooling water.
Yeah.
Okay.
This is a water cooled turbo molecular pumps. Once switch on turbo molecular pumps, wait, turbo should be ready. Wait 20 to 30 minutes. Then turbo ready indication is coming. After ready indication is come, turn the combination valve in roughing position. Before opening high vacuum valve, your chamber should be rough vacuum.
Minimum.
Minimum -2. Otherwise, if you go direct atmospheric condition should not go. We have interlocks. If you try to switching on, you're not getting on.
Okay. So
You
that
have
protection
interlocks. Protection will be there. Switch on close the backing valve and open roughing. Wait until reach better than 5 to -2 in chamber. Then after reaching -2, close turbo roughing valve and open backing. Then open high vacuum valve. When open high vacuum valve, then after open high vacuum, your turbo will be connected chamber.
Okay. Then it will start working.
Then they start high vacuum -5, -6.
So this hotel -6, usually this system how much time it will take?
1 hour.
1 hour.
Yeah.
You can say.
Actually, switch on means first water utility should be on. First switch on water, power, pneumatic. Then switch on means all indication is coming. All interlock safety will be on. See, safety interlocks, water cooling, source enabled. If water safety interlocks is not satisfied, your system is not getting on.
So system will do that checking.
Yeah. This should be healthy. This light to glow is on. Then start rotary pumps. This is
No, we will
yeah, this is HMI. You no switches actually. Here you can operate with HMI only. Just touch screen like that. You can do the manual rotary.
Oh, HMI, human machine.
Yes.
This is switch on rotary pumps. Wait until reach -2 vacuum. Then open vacuum valve. Turbo on. After turbo is getting ready, indication is coming. The turbo ready indication is coming. After that, then switch on turbo roughing valve. Wait until -2 millibar. Then go to high vacuum. Wait until reach -6. You will require base vacuum.
Okay.
-6
we
vacuum.
need for our
Then after reaching base vacuum, you can go for ion bombardment cleaning.
Okay.
You need ion bomb for cleaning your substrate. Before going to thermal evaporation, do the introduce the gas, inert gas. Take the pressure from -2 level in chamber. Introduce the water and give the current. Those plasma is be coming. It need 10 to 15 minutes.
So it is like a plasma cleaning.
Plasma cleaning, same plasma cleaning. After completion HD, you can go for again high vacuum one. Switch on LT, thermal evaporation. Before closing the chamber, you can need your substrate and coating material. Then you can start the work. Digital thickness monitors are all in video. During the coating, it will be shows what is the rate of thickness.
The thickness monitor, the quartz is inside.
The quartz is crystal is inside. Monitor will be here.
Okay.
It will measure the rate of deposition rate. What is
Kilo
the
Armstrong per
That
second
is per
and the
second.
Thickness, rate and thickness,
yes.
separate.
Will measure the thickness.
So what is L1, L2, L3 there?
That is
This is line 1, line 2, line 3. This
Oh,
is
three phase.
No,
Three phase
this is
power.
for indication.
This is 3 phase. Line 1 RYB like that.
Okay, fine. And the bottom are all circuit breakers to see if you have to reset or something.
Yes.
In like MCB, if you have to reset it.
Like
Okay.
After coating is over, just wait 10 minutes for cooling the substrate. Don't
Suddenly go for
don't vent the chamber immediately. Whatever your substrate is still hot condition, you go atmosphere is going inside, your sample will be black. Condense will go. That's it. Other you can do venting with nitrogen gas.
Substrate has to be cooled with vacuum condition.
Vacuum condition.
Oh, not in air. Yeah. So you like first the roughing pump will come.
Yeah.
-2 we will go to the TMP.
Yes.
And once after roughing pump comes, that valve will open, right? High vacuum valve.
Yeah.
Then turbomolecular pump will come in.
Yes.
And then if it reaches some sufficient pressure, we can start the process.
Actually, we have instruction manual. Will be given.
So here in the system, each of this switch is manual, right, or automatic? Manually we have to switch.
Just a touch screen.
Okay.
Earlier, old model is just butterfly valve. Manually open, close like that.
So here, how do we switch between E-beam deposition and thermal evaporation? I mean,
This is LT, HT.
See the EB
Yeah, circuit breaker will be
local connection and remote connection.
Remote connection.
If you put local connection means we have to operate manually.
Okay.
If you put remote connection, we will go for
HMI. No, my doubt is that we can do E-beam evaporation and thermal evaporation, right?
at a time.
No. Differently. Then how do we select which one we want to?
Source. If you want LTA source, we will go through this
Okay.
selection. If you want HT means we have to turn on this.
Okay. And the system has protection. If both are on, it should not work. No, that protection is there.
Yeah.
Both cannot be on.
Not both.
Okay.
India circuit breaker will be there.
Okay.
This is LT, this is HT.
So what is the rotary drive? That is for the roughing pump.
Rotary is for rotation.
Okay, so that rotation drive.
Yeah, speed controller also.
To adjust, you can adjust some RPMs.
Uh,
I need
10 to 15 RPM maximum.
Which one is which one? And then RPM value is not written.
No, that won't be there. He's telling we can switch between that much range.
We can set from 0 to 100.
So total like how many the wafer carriers will be?
Wafer carrier 4 inch by 4 inch 4 numbers.
4. Now I think we can open the chamber. that is the chamber he is showing.
EB gun, electron beam gun. We have a EB gun shutter. This is a pneumatic shutter. This is LT. This is thermal evaporation by filament, board or basket. This is a iron movement cleaning facility. This is quartz crystal.
Monitor.
Crystal board. Okay. Here the substrate holder is coming. This is dismantling. It will be putting back.
Okay.
Substrate holder.
Yeah, we will assemble and put it.
With rotation will be. This is now you provided a quick relief like a bulb. How we can fixing it like that.
Oh, okay. Rotate and tighten.
This is the new design.
Okay. So the boat is here. Boat will be here.
Here. This is board, filament, basket. Thermal evaporation. Here crucible is coming.
Okay. For your EV.
Actually, this is four source crucible.
Okay.
Can without breaking vacuum, you can able to pour material without breaking. Have a correct index also there. Can change out the source 1, source 2, source 3, source 4 like that. Have four crucible inside.
Oh, inside.
Yeah, this will be correct index will be there. When select the whatever source one, this will be rotating. This will be exposing here. Beam is falling inside the lens.
So we can manually control the shutter to open it.
Yeah.
To operate the shutter, we give a selective switch by doing this.
LT shutter.
LT shutter.
EBM shutter.
Okay. Oh, EV shutter is there. That one inside.
This is EBM shutter.
This is EV shutter. That is LT shutter.
LT shutter.
Okay. And that right side one is the QCM. What is this light one? This one?
This is HT, iron movement cleaning.
Okay.
HT.
That will be there for both processes. First is clean substrates. That cooling liquid will come
Plasma coming
from there. Cooling liquid will come from where? These pipes are for what?
This is water cooling for EBM.
Water cooling.
This is water cooling for crystal, water cooling for EBM. Have chamber cooling.
Chamber
Door also cooling will be there. This is door cooling channel.
Okay. And what this is grounding?
All safety will be there, sir. No shorting or.
What is this? Local and remote? These two?
Which one?
Shutter.
This is the local and the remote.
Remote we can use operate through HMI.
It can select the local, can switch on open manually. If you select the remote, can operate from HMI.
Okay, if I use local here, how to operate?
Yeah. If you use local means, we will operate here only. If you press lock, if you put
This is local, this is off, this is remote. Can you just touch?
Okay, if you put remote, then we have to operate from here. But if you put local, then automatically it will be open.
And some knobs is there to set the LT current.
This is LT secondary, HT primary.
ST there is no control. For LT we can give some set points. Like I need 20 amps.
Up to how much we can give?
The transformer rating is up to 200 amps is there. But we have to go with filament current. Depend on our board and filaments, baskets. That kind.
Okay. Only material should evaporate and not
Yes.
We provide up to 200 amps rating
Up to
transformer.
200 amp facility is there.
But the
Actually,
current
depends upon your material, coating material. What are the temperature melting points? You can see the window. Slowly control, current control will be here. And start operation and can set it.
That IO and reset buttons are?
sometimes HMI will not turn on suddenly, and that time you have to press it, reset.
Okay.
Suppose if any error is there, if you press reset, it will
What is IO?
IO, input output.
Reset. Sometimes what happens? Sometimes power is more.
Initially, I have to turn the
Sometimes any reverse current. That time it will be on.
Okay.
At that time you can press the reset button.
Okay, so IO is a status, not really a button, but reset is a button.
Yes.
These three are all status. There is no button there. No.
No.
These two
This is safe. This is also button. This is
Indication.
only indication. This is water safety interlock, water cooling, source enable.
Suppose without touching this indication, we will not move forward to switch on the sources. It has to come green. Then only we will move to operate the sources.
So when you tell safety interlocks, what safety interlocks do you mean?
Safety, water, power, pneumatic.
Or have locks?
Any shorting is safety. Without safety, it is no working.
It will not work.
It's not work.
It is not forward to process and all.
So when we do emergency stop, what happens? Everything is shut down.
Everything should be shut down.
But what is process is going on? I press emergency shutdown. So like what is the protection for the chamber or something like that?
Nothing.
It will be
Immediately,
venting.
highway will be closed.
Close. It will vent also. No.
Not better. Venting is not happen. Just close all the way.
Okay. Oh, the high vacuum all will close. Yes. Cut off. Yes. So what are things we'll fix now?
Yeah.
So this is the substrate holder. So the wafer will sit here. So these clips you can see. Usually people use either clips or Kapton tapes. Kapton tape is like a special type of tape which you use inside the clean room to fix and hold the wafer. But this is a better option because we come with SS clips. So you can unscrew it and put the wafer and then screw it back. So it will be tightly there. It will go like this, and this is where it will go and lock inside the chamber. He will show you. We will fix it, and you can keep the wafer here. So he has connected it inside. You can see it is locked also. It's like you put the bulb inside the socket. It's the same way.
This is like a quick relief coupler. Quick relief coupler like that. And screw tightening, remove very difficulty.
So one wafer at a time.
No, 4 numbers at a time.
Oh, here. Okay.
This is 1, 2, 3, 4. This is the bigger size. This is maximum size.
So this key is for opening this one, right?
Yeah. You put shutter also will be there. During closer, can open.
So you can see the plasma from here.
But without the shutter, coating will be happen in the main glass. Slowly, the view is not there.
Oh, okay.
To avoid it, provided is no shutter. Viewport shutter.
So we have a shutter, like he told, viewport shutter. So you can see the process. Whenever you do it, you cannot keep it always open because the glass will get deposited with the material, and over time you will not be able to see anything. So that is why this metal shutter is put, so that on the other side of the shutter, things will get deposited as process happens.
This is pyramid in spare. Actually, now it's not spare. Pyramid is gauge is spare. Over a period of gauge will be contamination. What will we do?
So what does each of the gauge measure? Can you explain?
Pyramid measure from atmosphere to -3 millibar. After -3, you can read a penny gauge. -3 to -6.
So already there are gauges inside. So these are spares in case the gauge, because the gauge is very important because otherwise you will not be able to monitor the vacuum that is formed inside the chamber.
This is Pirani gauge.
So this is the Pirani gauge. So the connection will give the value to the control panel, no?
Yeah.
From the gauge.
Yes.
from here through this Ethernet port, the information will go. The gauge will measure the vacuum level, and through the Ethernet port, the information will be transferred to the control unit.
It's both are Pirani. Pirani 1, Pirani 2.
Two Pirani gauge pairs are
There are two Pirani. One is backing line, another one is roughing line.
Okay. So both Pirani only.
Both Pirani and one is penning gauge for chamber vacuum. Yeah, actually normally we use two Pirani, one penning. One Pirani is measuring from back side, back vacuum, and the chamber vacuum.
Okay.
And then minus. All the question manually.
Prefer to what?
And you prefer
First to open?
but the other close mode.
Okay, that is fine. So we have a spare penning gauge, but we are not opening it because of contamination issues. Because it's very important, so it's there kept. The one gauge is installed already in the system. Correct? Yeah. So what is the lifetime for these gauges? Like how often we have to replace it?
Nothing. If you malfunction, you can do the recalibration. So any major problem or gauge is not working, you can replace. See, once in the year should be calibrated.
So he will come and calibrate. Okay.
No, you will be sent it back to the office. We
Only
have
the gauge
calibration facility. Yes. We have all in-house calibration facility.
So we will remove the gauge and send it to you. You calibrate and send it.
Suppose if there is any error means you can calculate, otherwise you can use normal.
No. But how will we know error is there? Because that is the one that is telling us the pressure.
To measure that some master gauge is required. Means to find out that errors, you need one master gauge. But here not available. You can identify easily that errors. Certain times that
Okay, we know that in the process after half an hour we should reach this pressure.
Yeah.
It is not showing the pressure.
Okay, this is the crucible. Tungsten crucible. This is graphite crucible.
Okay, so these are the crucibles where we will keep the material that we want to deposit. So this is tungsten crucible. So why we have different materials is depending on the melting point and what is the process that we use. Accordingly, we have to use the crucible.
Moly and graphite crucible.
So this is what?
This is
molybdenum. This is a molybdenum crucible. This is graphite crucible. So
molybdenum boards.
these are molybdenum boards. Instead of crucible, it will be like a board. So you can see the shape is like board only. So this will be a rectangular.
Using for thermal evaporation.
Yeah, this is thermal.
This is EV.
So the crucibles are for EV, boards are for thermal evaporation.
LT.
This is a basket.
This is also for LT purpose.
This again like crucible.
Yeah, some different shapes.
Tungsten basket.
It is basket shape, that is boat shape.
This is
This
what?
is a crystal. One set of crystal.
This is tungsten basket. Tungsten basket, graphite crucible, molybdenum crucible, and molybdenum boards. Boards are also molybdenum.
Basket and boat for LT, crucibles for EV.
So the basket and the board, two things are for carrying the material in the thermal evaporation process or LT process, and the molybdenum and the graphite crucibles are for the EV evaporation process. This is spare for the material.
Spare will provide.
Crystal holder.
During your discussion, we saw the discussion to providing minimum consumable item. Okay. That's why you use it. Okay.
These are crystals, so you can, as we have seen inside, there is a quartz crystal monitor inside. That is very critical because that measures the deposition rate and the thickness that is deposited. So the thing is, the crystal also gets deposited, in the process.
Yeah.
So we have to quite often change the crystal. Otherwise, our calibration of the thickness measurement will get affected. So they have given spares. 10 crystals are there, which we can replace. So now we have connected the power supply for the control panel. We have connected the substrate holder into the chamber. We have removed the vacuum from the chamber. We have seen the roughing pump and the turbomolecular pump below the chamber, as well as the transformer there. The next main things are connecting the gas supply, gas flows, connecting the chiller unit, connecting the compressor unit, as well as powering on the entire system. So then we will be able to see the system turning on. We have seen the control panel front side, but this is how the back side of it looks like. This is where all the electronics, power supply, MCBs, everything will be there. Whatever power supply we pushed is here, sitting here. This is the connector for it. This will go outside to the socket that is on there on the wall. So we'll ask the team to explain what is this. Actually, sir, can you explain a little bit? Yeah.
See, initially when we turn on the system, initially this fan will get on. To cool all the accessories like thyristor, and we give on 24 DC power supply for control circuit purpose, and also DTM also is there inside the DTM, and transformer is there. For all the accessories cooling purpose we give on fan, and HMI also is there. Then see, suppose sometimes if some selective switches will not getting on that time, we have to troubleshoot. On that time we have to observe MCBs also. Suppose some MCBs are tripped or what, like that type. And this is called a contactor and thyristor 24 DC supply. This is for control circuit. We given 2 numbers control tray, 1 and 2 numbers. Then that's
power supply. So where will be the intelligent like processor board and all, where it will be control board will be here only inside the HMI.
That is we already programmed.
So these are all valves only, electric valves, like switching and all.
It is only
knob and all.
No.
Only controls.
Yeah.
Relay switches and all will be there. That's all.
Yeah. It is only control circuit.
Okay. No processor and all.
No.
Okay.
Some relays is there. By that we will
control.
By that we will control. That is already programmed in HMI screen.
Okay. This one is what actually?
It is to operate the EB source. We are given 3 types. One is EB motorized turret. To select the source position is there. In EB gun 4 source selective pockets is there.
Okay.
To operate that motorized turret drive, it is.
Okay.
It is EB3 beam
That
sweep
controller.
unit.
That
Beam
controller,
sweep
sweep
unit means,
controller.
in EB gun we will get X and Y axis now to get that waveform. If you want X form or Y form, we'll go through this beam sweep unit.
Okay.
To set that axis.
Okay.
X axis, Y axis, and that control of the waveforms.
Okay. Of the electron wave.
Electron
And for turret movement, you have the first one.
Yeah.
Motorized turret movement. Yeah.
That is one control unit there.
This is the DTM, thickness monitor.
Okay.
Connection.
So that from the QCM it will come to this. I mean the crystal it will come to this.
See here, this EB motor turret indexer. This EB beam sweep controller. This is the
High voltage means to select the EB gun power supply current and voltage.
Okay.
It is called one controller.
Okay.
By this controller we can set the EB gun current and voltage. We can monitor from this.
Okay, so from there through that connector it will go to the power supply unit directly.
Yes, already interconnected with this cables.
Okay. So those cables we will connect to this now.
Yeah, we have to monitor from this controller.
Okay. That white color is the DTM monitor. It will show the thickness
Yeah.
monitor. So internally we have to switch it on also. That will be on, no? So it has a separate fuse of its own. Basically.
Yeah.
Okay.
That switch will come outside of the front panel only.
Okay.